the sun, our life-giving star. For over 4.5 billion years, it has been the center of our solar system, providing warmth, light, and energy to sustain life on Earth. But what if tomorrow the sun were to explode? What would happen to our planet, our solar system, and humanity itself? Tonight we explore this terrifying and fascinating scenario. The sun, a giant glowing sphere of gas at the center of our solar system. It's the source of light, warmth, and energy for all life on Earth. But like all stars, it has a life cycle. Our sun is a middle-aged star, about 4.6 billion years old. It's currently in the main sequence phase of its life, where it has been for billions of years, steadily burning hydrogen into helium. But this stable phase won't last forever. The sun is a massive ball of hot gas, primarily hydrogen and helium, undergoing nuclear fusion in its core. But like all stars, it will eventually run out of fuel. In billions of years, it will swell into a red giant, shedding its outer layers before quietly becoming a white dwarf. In about 5 billion years, the sun will begin to exhaust its hydrogen fuel and will expand into a red giant, engulfing the inner planets, including possibly Earth. Eventually, it will shed its outer layers and leave behind a dense core, a white dwarf. This process is gradual and relatively predictable. However, a sudden explosion like a supernova is extremely unlikely for a star like our sun. Supernovae typically occur in more massive stars, yet the question remains, can we predict the end of a star's life, whether through a supernova or other catastrophic event? But let's imagine a different scenario, a catastrophic event where the sun explodes tomorrow in a massive supernova. The first thing to understand is that the speed of light governs everything we see. At 93 million miles away, it takes about 8 minutes and 20 seconds for sunlight to reach Earth. So if the sun exploded, we wouldn't even know it until those final rays of light arrived. To predict any potential disaster, we must first understand and monitor the stars. Scientists have developed advanced technologies to observe the sun and stars throughout the galaxy. Solar observatories, both on Earth and in space, constantly monitor our stars' activity. Solar observatories like NASA's Solar Dynamics Observatory and the Parker Solar Probe. These instruments watch for solar flares, coronal mass ejections, and other signs of solar activity. But beyond our own sun, we observe distant stars, studying their life cycles and learning how they behave as they age. Hubble Space Telescope, James Webb Space Telescope, and other observatories looking at distant stars. By studying other stars, we've learned to recognize patterns and warning signs that might indicate an impending stellar explosion. When the explosion occurs, it would release an unimaginable amount of energy, blasting through the inner planets, incinerating Mercury, Venus, and turning Earth into a scorching wasteland before the shock wave even hits. Impact on Earth. The arrival of the shock wave and energy. Atmospheric effects. Fires, radiation, and destruction of the ozone layer. The onset of darkness and rapid temperature drop. As the shock wave and radiation from the explosion reach Earth, the atmosphere would ignite, causing widespread fires and massive destruction. The ozone layer, our planet's shield against harmful ultraviolet radiation, would be obliterated, exposing all life to lethal doses of radiation. In a matter of seconds, the temperature would plummet as the planet is cast into darkness. Without the sun's gravitational pull, Earth would drift off into space, a frozen, lifeless rock. The destruction of the sun would have catastrophic consequences for the entire solar system. Without the sun's gravity, planets would no longer follow their stable orbits. Some might collide with each other or be flung into deep space. The asteroid belt would be destabilized, sending countless rocks hurtling in all directions. From a galactic perspective, the explosion of our sun would be a minor event, barely a blip in the vastness of the Milky Way. But for the planets that once orbited it, the consequences would be absolute and final. Could humanity survive such an event? In the few minutes we have before the shockwave reaches Earth, there would be no time to escape. But let's consider a scenario where we had foreknowledge of the sun's impending demise. Even with years of preparation, escaping to another planet within our solar system might not be enough, as the entire system would be destabilized. The most viable option could be traveling to a nearby exoplanet in another star system. However, this presents insurmountable challenges, including the vast distances involved and the need for advanced technology that doesn't yet exist. The reality is, even with the most optimistic projections, our technology is far from capable of such a feat. Humanity would be faced with the stark reality of our own fragility in the cosmos. Our sun is stable, and the chances of it exploding tomorrow, or even in a million years, are virtually non-existent. But the very act of asking "what if" pushes us to learn, explore, and advance our technology. In the vastness of space, the more we know, the better prepared we are for whatever the universe might throw our way. But while we rest easy under the sun's warmth today, let's continue to look up, to study, and to prepare for the future. Because in the grand scheme of things, predicting the unpredictable is how humanity survives and thrives in an ever-changing universe. This script delves into the scientific methods and technologies that might allow us to predict a catastrophic solar event, along with the potential responses humanity could take. The narrative balances scientific accuracy with speculation, creating a thought-provoking and informative piece for the audience.